Hello friends, welcome to my channel. Let's have a look at problem 652. Find duplicate subtrees. This is a daily challenge problem. So in this video, we're going to explain a solution based on serialization and counting. First, I'll read through the problem statement, and then we explain the general idea, and finally we do the coding, and in between we explain the code line by line. First, let's look at the problem statement. Given the root of a binary tree, return all duplicate subtrees. So for each kind of duplicate subtrees, we only need to return the root node of any one of them. So two trees are duplicate if they have the same structure with the same node values. So here are several examples. So in example 1, so for example, the subtree rooted at this 2, we have 2 and a left subtree 4. So similarly here we have 2 and a left subtree 4. So 2 is a duplicate tree. So similarly for the leaf nodes 4, right? So we also have this one. So in example 2, so we notice that the two leaf nodes as a subtree themselves are duplicates. So we have 1. So here you can see this 2, also this 3 as leaf nodes. So basically from these 3 examples, you can sort of gain a feeling about the problem. So before we move forward, let's look at the constraints. The number of nodes in the tree will be in the range, so 1 and 5,000. So this is actually not very large in some sense. So here the node value is in between -200 and +200. So with that said, let's look at the treatment here. So in this solution, so we are going to follow an idea based on serialization and counting. So the idea is the following. So we serialize each subtree in string format. And then if a string appeared before, then we meet duplicate trees. So for the serialization, so actually we could use whatever meaningful string representations as we like, such as in order, pre-order, post-order. And sometimes we need to use some separator. So here we can use any symbols as we like. So we can use pound, star, or hyphen to distinguish with digits. So while do the counting, so actually we can use dictionary. So we can either use the vanilla dictionary class in Python, or we can use a subclass called default dictionary. So in this problem, we don't need to do the revert part. So in other words, we do not need to do deserialization. So therefore, the serialization step is full of freedom. However, we'd better be aware of these cases. For example, we have a root node with value 0, which has a left subtree with value 1 and a right subtree with value 2. Or we have a root node with root value 0 and a left subtree with digit 12, right? So similarly, if you can replace the left by right in the above line. So we need to use separator here. So if we do not use separator and we just do naive serialization by traversal, then all the 3 trees above might have the representation like this, 0, 1, 2, right? So in this case, I'm using a pre-order serialization, so to speak. So we need to keep this in mind. So once we done the problem, once we finish this problem, so we could print out the auxiliary dictionary for illustration. So here for this problem, so I'm going to just follow the above idea. So let's first do some preparation. So for the counting, so we can use collections and default dictionary. So here, if let's use a default one, integer, and then I'm going to initialize a mutable thing. Object is an empty list, and then we're going to write a hyperfunction. Let's call it DFS or a traversal. Let's see. Give a node, and then the role of this function is to modify this list, and in between we get the representation of serialization of the tree represented by the node. So first, if not node, so basically we have null tree, so we're going to return null. Or if you like, you can return something like this. This is still okay, but here let me return null. And then we're going to do recursion, so we can get left subtree and right subtree representation. So it's DFS node left and DFS node right. So this way we can get the serialization string for the left subtree and the right subtree. So we need to join or concatenate them in a way so that we can store the tree. So here, let's do this. Let me introduce an additional variable using fstring. So this is just for explanation purpose. So in practice, you can do whatever you want to do. So here, I'm going to have the node value. And then we want to get basically left subtree, right subtree. But here, we want to use some separator, right? So here, we can use C star. So then we get the representation or this serialization string for left subtree, and then the right subtree. So, or you can write something like this: the right, so left, just to distinguish. So here, notice that we don't need to do deserialization, so we have freedom here. And then we are going to because this S will be the serialization string for the current tree represented by the node. And then we're going to increment the counting of this serialization by 1. And then if counting is greater than 1, or let's see, S is equals to 2, and then we say that we have a duplicate tree. So in this case, so we're going to append the current node. So this is this node, you can regard it as a node or regard it as a tree, right? Represented by this node. And then what we are going to return in this one is the string S. So this gives us a very brute force way of doing serialization. And then what we're going to do here is we call DFS the root, and then we're going to return the result. So this is the whole logic for this problem. So before we make comments, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. It passes all the cases. So in order to better understand this this piece of coding, so let's print out this counting, right? So the counting holds the representations of each subtree. So let's see. This is the counting. So for example, this one, the leaf node 4. So in this example here, appears 3 times, so to speak. So this is basically a full solution to this problem. So here, the casing is the serialization here. So you can do using different orders. Let's see. Here I'm writing L. So you can add this part. Let's see. Call this one L. So then we can add this one, and then we can have node value. So this will also work, I guess. Yeah. So basically we have a lot of freedom, but if we want to also do deserialization, we need to pay attention to the way we do the serialization. So that's about it for this specific problem. In a follow-up video, we're going to look at another problem which requires serialization and deserialization. You're welcome to follow up. With that said, I guess that's it for this problem and this video. Thank you.